So hi everyone, welcome to my channel. So in this particular video, we are going to know about word embeddings. So, so two types of word, two types of process in word embeddings we are going to watch, and one is like we have to use that Word2vec library. Mm, So using that only we are going to train our own embedding, as well as we are going to see about the Keras embedding method. So we'll use the deep learning Keras library and train our own word embedding. So let's see. Let's start with the first, how to create own word embedding using Word2vec library. Then we're going to see about Keras library. Okay. So suppose this is my sentence. As you can see, I have provided some sentence, right? So few sentence I have listed down. Let's run it. So as you can see, those are my sentences. So this is one sentence. This is my second sentence. So I have some one, two, three, four, five sentences. So I have tokenized it. So tokenized means what tokenization. So each sentence, whatever words are there, so I have segregated each word because I have to train or feed the machine with these particular words, right? Individual word in a particular sentence. So in Gen Z model, we have to import the library, Word2vec library. So in this particular library, it is a pre-trained library. So use we have to use that to create the vectors of our individual words. Okay. So how are we going to like what we are going to give this particular Word2vec library? So first sentence token. So all the tokens of words for every sentence we have to provide. And size means what is the dimension, or you can say what is the features or dimension of each word. Suppose this word high would be um, represented as 100 features, right? 100 features means you can see 100 features. Suppose there is a word like what is a learn. So learn could be represented as 100 features. 100 features means learn is a person, or learn is some word, learn is some noun, or learn is a teachable word. So you can think about various features. According to the feature, we give some numbers, right? So you can consider that as well. So each words in the token would be divided with 100 dimensions. Then window size means 3. If you know about if you know about what CBOW and skipgram, then you have to you will understand that window size 3 means we have to taking this 3. Then for 3 word we're taking these three neighbors of word, we have to predict late. So if you go through the CBOW and skipgram video, then you will understand what is basically Windows 3. So as of now you can understand Windows 3 means we are navigating through 3 words to predict a high. Like the first word we want to predict, so we have to go through these 3 words. So we have to consider these 3 neighbors and to predict this particular word. And we'll move to next one. Then we have to take these 3 neighbors to predict this late. So like this, it will machine will do what? It will try using these 3 neighbors. It will try to gather the context of this particular word. And minimum count is something like whichever word is at least repeated one, at least. So repeated once only, not repeated once means is not repeated once. So minimum count is what? Whichever word is only there for once, we can take this. Suppose if our vocabulary is huge, so and many more numbers of words are repeated many more times, so we can increase the count number. As our vocabulary size is small, so we can take us one. Worker means we can see the course number of courses. So I have 4 courses, so I have divided as workers. I have specified workers 4. So you can see I have trained my model. So you can see each of my vocab. So these are all my words in the sentences, and as of you as you can see, these all are my words in the vocabs that actually our machine or Word2vec model is trained on. If you go through the each word, so there is a word called data, right? Data is there, I think. So there is a word called data that is also in our vocab. So if you take the particular word and see, these are nothing but the vector, like 100 vectors of this particular word data. It is trained. It has like the Word2vec library has trained this particular word. It is created 100 features or 100 dimensions of this particular word. If you go through the word cricket, so you can see what is the most similar words. So how it is calculating most similar word, it has like each word's vectors has been taken out, and we are calculating the cosine vectors of each word. Like each word is represented in 100 dimensions. The data word also represented as 100 dimensions. So how it is, and cricket word also represented as 100 dimensions. So how it is related to cricket data for football, it is saying like it is calculating the cosine similarities between 100 vectors of each word, right? So most similar word is saying is data than football, so it should be mostly predicted football. But as we have very less like less number of vocab size, so there is less training data, so it has not predicted that much well, but it's okay. That is one more disadvantage of it. Like if you go through, as we have very low or less number of vocab size, in our vocab size only this many words are there we have trained on, right? So if we put any different word rather than in our vocab size, it will say like the word hockey is not in our vocabulary. So this is one advantage of taking our own small data. If we have large vocab size, then it will be fine to take or time. If we have large vocab size, then we could have taken our own Word2vec library. So this is okay. Let's see about training our own embedding using the Keras or embedding method. We have to use the Keras library from TensorFlow to treat the or to check the word embeddings. And let's see, we are going to do one prediction as well. So what is the prediction like? We have actually taken some sentences which are spam data and no spam data as well. So let's check in the table menu so that it will be easily visible. So this is a sentence, and we have assigned some numpy array, and we actually have converted to data frame, so it will be good to see that. So this is nothing but the data we have taken. So let's convert to table. So if you can see, I have labeled it free message. Hey there, darling's been 3 weeks now. So Word2vec, so it's a spam. Okay, so you can say it's a spam message, and we know that this is also spam. This is also spam. This last three is not spam. So whichever not spam is there, I have labeled it as 0, and whichever the spam message, I have labeled it as 1. So let's train our model using Keras, using the small data. Let's see how it is working. So I've taken message column. So this is my message column. So I've taken message column, and I have cleaned this, like whatever there is except letters. I have just removed it with the space, and have treated with photo stemmer as well. So that each verb would be converted to the base word. Is base word, right? So this is nothing but the clean data. Let's clean our data. So it has cleaned now. So actually I'm printing the number of sentence that is there to clean. So 1 2 3 5 6 6, we have 6 sentence, right? We have 6 sentence. So we have taken it, and what is the what this function actually returning, this function is returning the clean corpus. So if you go through the corpus, so we have 6 messages. So this is the first message, this is the second message, it is cleaned and converted to its base form. So we have clean messages there in our corpus, so we can apply our deep learning model as well in this particular cleaned words. So first we have to do encoding. So how we are going to do encoding? Suppose we have these many words, so we can do one thing. As you have these many words, so you can check, there is also one method we can check what is the unique words. Suppose I have taken for a buffer purpose, I have taken 50 unique words. Unique word vocab size means what is the unique words in your corpus. So I have taken, suppose I have 50 unique words in my corpus. So for that each unique word I need to encode it. So one not encode, actually we can import it from TensorFlow or Keras processing text. So I have to convert it to some numbers before sending it to embedding layers or deep learning layers. So I'm getting each sentence. So you can see it should have great sentence like for sent in corpus. So whatever sentence in the corpus, so this is one sentence, right? And this is my second sentence. So each sentence we can send it to this particular one not function. So after that we need to specify the vocab size. So what is the vocab size? What is the total number of unique words are there? So I have taken 50. So it has converted each word in a in some number, keeping this range 50. So each words are each words have been converted in numbers in between 50 range. So you cannot see any word above 50 because my range is 50. Because range is 50 means there is 50 numbers of words. So each word could be converted as some indices of between 1 to 50. Suppose this particular sentence we can take. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 17 words are there. So you can see 17 numbers should be there in the first sentence. This is my first sentence. So 3 3 3 3 3 15 16 17. So all 16 words have been converted to numbers. So after encoding these numbers, what you can do? So you can see there are different size of words in every sentence. This is my first sentence, it has some 17 words. This is my second sentence, it has some less words. In third sentence, it has some 18 words, larger number, and this sentence has a smaller number of words. So length is different. So if you send these different types of length to our model, so it will create a problem or it will create an error. So what we can do, we can pad zeros whichever has smaller number than the maximum number of our sentence length to have each sentence have same length. So you can at least pad 0 at least from the starting or from the last. So here actually I have used from the starting, so I have used pre as argument. So what I am doing is pad sequence also you can input from here, so from Keras. So what we can do, we have to send this particular one hot representation of each word, then pad, then what is the maximum length. So you can say this is my highest number of length. So in between, so I want this particular length for each sentence. So you can take 10, like you can take this particular number, or you can say you can take as buffer 20. You can more than that particular number you can take. So the maximum length is this sentence. So I have 18 number of words in sentence. So I want every sentence to have 18 numbers. So you can see whoever has less than 18 number of words has been paired with 0, right? So all my length of the sentence is same now. So after that what we can do, so after that we can define a model. After that we can define a model. So how can we define a model? You can see. So this is sequence model. So in that sequence model, we can add number of layers. The first layer I want to add as embedding layers. So this is my embedding layer. What embedding layer? Then only I'll train, like how I'll train. So I have to add the first layer as embedding layer. So embedding this layer nothing but what the parameters is taking. So it is taking first vocab size. Vocab size. What is vocab size? Vocab size is total number of unique words. Unique words in my corpus, right? So vocab size is like I have taken 50, right? I have taken 50 as my vocab size. Then feature size, so each 50 word, so I have 50 unique words, right, in my corpus. So each 50 word, each word will be represented as 100 features, right? Like this you can see that in our Word2vec also have done what I have provided size, right? So each word, so here actually this many words are there. So each word has been represented as 100 vectors, 100 vectors, right? Like this word, 100 vectors has been represented. So like that only I want to use here. So I want my all my vectors to have 100 features, like 100 vectors. And input length. What is the input length? Input length is what is the length of each uh, sentence carrying, right? So my input length is, so this many length is my input, so 18, right? 18 is my input length. So then whatever the outcome it is coming, so I have to flatten this. Then after flattening, actually I have used one neuron, like last layer is one, because I have to predict what I have to predict whether this particular sentence, this particular sentence is spam or not spam, right? So I have to define my model here. So after defining, let's see the summary. So what is the summary saying? So this is number of you can say number of neurons present. But what is the what is the uh, what is a trainable parameters here? Trainable parameter is showing 5,000. Why it is showing 5,000 means, so I have 50, what I have 50 number of vocab size, or 50 number of unique words. So as each word is represented as 100 vectors, so 50 into 100 means 5,000 trainable parameters. And 18, why it is saying 1800? This is the neuron size. So I have 18 words in a sentence, and each word would be represented as 100 100 vectors. So these many neuron size I have. So these many neuron size are there, right? So if I have to flatten means each neural size will be come to a single dimension vector, right? If you know flatten. So 18 into 100 would be 1800. And last one is my dense layer. Dense layer is nothing but a single neuron, because I want to predict just a sigmoid activist function will predict what? It will just predict 0 to 1 number. So whichever less than 0.5 would be predicted as 0, and whichever would be predicted as 0.5, greater than 0.5 would be predicted as 1. Okay, so where is my, okay, so let's compile my model. So for compilation purpose, actually compilation means it will do the back propagation, right, to minimize the loss. So loss as it is for binary output, so I've taken binary cross entropy and optimizer as Adam optimizer. Okay, so let's treat our embedding docs, like whatever embedding docs that I have, this is my embedding docs. Okay, so this is I'm passing to this neuron, and passing 100 like 58 epochs. So this is my training happens in my model. So if you can go through, like the training has already done. If you want to see, so what I've told you. So one thing I need to show you. So embedding layer, like I have named my layer, this embedding layer, while training, while defining a model I have named this particular embedding layer, as embedding, right, as you can see. So I can do one thing, I can show the weights. So the weights are nothing but the vectors. So if you can see the first word, as you can see, this is my first word, vectors. This is my trained weights. So this is actually features. So how many features that I have told you, how many features are there? So I have told you 100 features, like 100 features, 100 features I should be there. So each word, while training, and doing the back propagation, the weights are already what's optimized. So after optimized, so whatever the weights each word carrying, these are nothing but my 100 features, right? So this is my trained weights. You can use in further other prediction as well. You can save it in a particular folder and use it for other prediction of what I'm doing. So this is nothing but my trained weights. This is my features, as you can see. Suppose you want to see the feature, the 100 features of an individual word. So you can go like that. You can see, suppose this particular word, uh, you can check, okay, any word you can see. Suppose I want to check this particular winner. Okay, so I want to check this particular winner word. So you can see this is my second sentence, right? This is my second sentence, and for what is the number, like number it has encoded. So for second sentence, winner is encoded as 4, right? 4. So you can see, you can go and check what is the features. So you can go and check what is the, this is my word, no, nothing but the word. I have to save it. So whatever the results we have, so I have to save it. So if you go through and check the length, you go through and check this particular weight length, so you can see 50. So 50, it carries, this particular weights carries 100 features of how many words? 50 words. So this 50 words means 50 unique vocab size that we have sent to our model, right? So each 50 word carrying this particular this particular 100 weights or 100 features, you can say 100 dimensions also you can say. So you can check, okay, so actually we are finding winner word. So you can see this 4 actually represented as what? This 4 actually represented as this particular word, right? This particular word, winner. So this winner actually converted to this particular 100 features, 100 dimensions. Similarly, we can do one thing, we can take other words, suppose win, right? Win. So this is the one two three third sentence, third word. So one two three, third sentence, third, one two three, so it is one. So you represent it as one. So you can go through and take what is the length of this, what is the vector of, or you can say features of this particular word. So this is for word what, this is for word win, and this is for word winner. So if you want to calculate the like how similarity, so you can go through and take these particular vectors, and these particular vectors you can calculate the cosine similarity. So you can find out how similar these particular words. So this is moreover, this is nothing but basically the weights that has been trained, weights that has been our deep learning model trained. So these words only nothing but treated as vectors, or you can say dimensions, or any other words you can name it. So let's predict using this particular model. So this model actually we have created, right? So which model we have created? So this model 3 actually we have created. So let's check, let's do one prediction. So I have taken how many, three or four sentence. So we have taken three sentence. So if you can check sentence. So we have taken three sentence. So one is this particular is spam. As you can see, this is also spam. This is not don't. This is not spam. So let's predict this one using our model. Let's see. So I have to clean it. So before sending to the model, as I have done while my training pre-process. So pre-process also same type of process you have to do. So then I have to check my corpus. So these three words have been converted to clean sentences. Then same procedure we have to same one had encoded for each three sentence. So three sentence has been encoded, and also we have to use the pad sequence because the number of words have been different in our predicted data. So after that we can do one thing. So this thing we need to cut it out. Let's delete this process. Let's delete this. So prediction means this we are taking this particular model and whatever the embedded docs. So embedded docs means this is nothing but our embedded docs about a prediction data, right? Then we have to do the predict. So it has predicted perfectly. So one is for spam, right? And zero is for not spam. First two is saying one means first one is spam. Third one is not spam. So you can see the first two is spam. This is not spam. So it is working perfectly fine. So we have taken a very small what to say very small training data. Very small means I have just taken six sentence. So it is working fine. So we can take large vocab for last sentence. It will work pretty much well. So this is all about word embeddings. So whatever you have doubt, you can post in comments. So thank you guys for listening.